scholars, let's keep on going here. And these examples are just quick, easy examples of applying what we've learned. So for instance, on this first one, a woodworker constructs a rectangular picture frame so that the length of segment JK is 50 centimeters and the length of segment JL is 86 centimeters. Find the length of segment HM. So what's the first thing all good math students do? Especially geometry ones. That's right, we mark up the diagram. First of all, I know it's a rectangle, so I'm going to put the right angle there just to kind of remember that. Also, we just learned a new property about rectangles, and what's that property? That they are congruent. So that means they also bisect each other and are congruent. So I'm going to mark those, and then I'm going to add the information in. Like they tell me the length of segment JK is 50. Well, that doesn't really help me much. But I do know the length of segment JL is 86 centimeters. And I'm looking right here for the length of segment HM. Well, that's X. Well, how can I calculate that? That's right. We know it's half of it. So the length of segment HM is just 86 divided by 2, which would be 43 centimeters. Just using the properties of the diagonal. Now, on the next one, it says CDFG is a rhombus. What do you know about a rhombus? First things first, you should always say, oh yeah, I know all the sides are congruent. So that's always what I mark first when I do these. All the same. Now it says look, and normally I say, hey, if both diagonals are drawn, draw in the right angle. But this time it doesn't really matter about the angle because we're not worrying about angles as much as the side lengths. So I'm looking for CD, but I know CD is the same as CG and GF, so I'm going to sit those two equal to each other. So I get 5A is equal to 3A plus 17. Subtract 3A. You get 2A equals 17. Divide by 2. A is going to be 17 over 2. You can leave it as an improper fraction as long as it's reduced. Now, that's not what I'm asked for, though. I'm asking for the length of segment CD. To keep it easy on yourself, it's a lot easier to multiply fractions than it is to multiply and then add. So I pick either one of these, but I'm going to pick CG because it's a little bit faster math. So I know the length of segment CD is the length of segment CG because they're a rhombus. I plug it in. 5 times A. Well, that's 5 times 17 over 2. But remember, when you're multiplying fractions, we make a whole number over 1, and then we multiply numerators and denominators together. And that gets me 85 over 2. For those of you who like to say 42 and a half, okay, I'm good with 42 and a half too, but let's try to remember to leave it as fractions. Now, hopefully that makes a little bit of sense. Now the next one is actually a remember when type procedure. I want to review a whole bunch of stuff that will help us prove things in this chapter, but it also allows us to apply what we know. It says here, show that the diagonals of the square EFGH are congruent, perpendicular bisectors of each other. So here's our diagonals. FH and EG. So I mean, as good as I'm going to get to drawing those. And I want to show that they're congruent. Well, congruent means same length, right? So how do I show that they're congruent? What formula do we use? Exactly. If you said distance formula, you are so right on. Remember, distance is finding the length between 2 points. So we go x2 minus x1, that quantity squared, plus the quantity y2 minus y1 squared. So what that allows us to do is plug and chug in for the length. So let's go ahead and solve for EG first. The length of segment EG is the following. x2 minus x1. So I'm going to go 3 minus a negative 4. Notice I put my negatives in parentheses. Oops, that should be a plus sign to keep track of negatives. And then I'm going to go 0 minus a negative 1. So when I do that, I end up getting 3 minus negative 4. Well, that's a positive 4, so that ends up being a 7 being squared. The 0 minus a negative 1, well, that's 1, so that's 1 squared. So that ends up being 49 plus 1, which equals the square root of 50. Well, that reduces down to 5 root 2. Now, if you don't remember how to simplify radicals, we will be reviewing that next week, so just make sure you have those down. But right now, just leave it as 5 root 2. That's the length, notice no bar over the top, of EG. Now, if they're congruent, FH has to be the same thing. So I'm going to use exact same formula, different numbers this time. So X, let's go 0 minus a negative 1 again. So 0 minus a negative 1 squared plus the quantity a negative 4 minus 3 squared. Well, that ends up being a positive 1 squared. And I have the quantity of negative 7 squared. So that's 1 plus 49. That's the square root of 50. That also ends up being 5 root 2. They have the same length, so they're congruent. Check. Congruency is figured out. Now I want to show that they're perpendicular. Now this I need you to go back to chapter 3. The way we showed perpendicular lines is we knew the slopes were opposite reciprocals. So now we're going to actually have to solve for their slopes. Remember, slope, okay, is the formula m equals y2 minus y1 over x2 minus x1. Okay, so now I'm going to still use the endpoints of my two line segments, and if I get opposite reciprocals for slopes, I know they're perpendicular. So let's do the slope of segment, let's just go EG first, okay? So we're going to go 0 minus a negative 1 over 3 minus a negative 4. That's 1 over 7. Don't have to reduce it, so we're finished. So that's a positive 1. Let's do the slope of our other one. Slope of segment FH. I'm going to go negative, 0. I got to do my x's first, my y's first. Hello, good day. I got to do my y's first. So I go 0 minus a negative 1 over a negative 4 minus 3. Well, that ends up being a positive 1 over a negative 7, which is the same thing as a negative 1/7. So the cool thing is, what do I know about my, did I just do something wrong? I did. My math was bad here. I did the most common error with slopes that there is. Did anyone catch what the error was? Yeah, my error was I switched my x's and y's around. See, even math teachers make those mistakes. So let me go ahead and fix it over here. I'm going to do the slope of segment FH over here, and hopefully I'll wake up and smell the coffee a little bit more. So let's do the numerator. Let's go negative 4 minus 3, my y's, y2, y1 here. So negative 4 minus 3 over 0 minus a negative 1. So that's a negative 7 over 1. Now I can compare these. Those are opposite reciprocals, so they're perpendicular. Check, we're good. Now the last part is we have to find that they're bisectors. Well, let me tell you the easiest way of doing a bisector. Bisectors go through what point? The midpoint, exactly. So that works out really well. It goes through the midpoint of those. So our midpoint formula, if we remember, is going to be x1 plus x2 over 2, and we get y1 plus y2 over 2. So let's do the midpoint of EG first, okay? So the x's add together. I got a negative 4 plus a positive 3 over 2. Our y's, negative 1 plus 0 over 2. And what I got was a negative 1/2, negative 1/2. Now let's hope the other one is also the same spot, and then we know they're perpendicular bisectors. So midpoint of segment FH. So the x's, what am I doing here? Negative 1 plus 0 over 2. And then I got 3 plus a negative 4 over 2. And I still get negative 1/2, negative 1/2. They're bisectors. Notice how that works. And we just reviewed 3 key concepts from the last chapter. All right, now let's do some more application of this. We have one last page. I said that before, I know, forgive me. One last page, and we'll get this one done.